Assalamu alaikum everyone. Hope you're all fine. Welcome back to my channel. This is my video on Computer Science 9618 paper 2, and the topic on which I'm making the video is ADT abstract data type, and today I'll be covering one of the ADT, and that is the stack. So let's begin. Abstract data type, first of all, it is collection of data, and then it is the set of operations on that data. All right. So first of all, it is the collection of the data, and then set of operations on that data. This is the first thing that you need to remember. And then now there are different types of ADT. So number one is stack, number two queue, and number three is linked list. All right. So today we'll be discussing I'll be explaining the stack. The stack ADT. The stack ADT is basically an ADT that is based on, that is a data structure in which the data is stored on the LIFO principle. Last in, first out principle. So the item that will be added in the last will be removed first. All right. So stack. So the items, they are always added. The items or the datas are added from same single side. Right. From the same end. Data is always added from the same end. All right. Example, before we move into its technical detail, let's understand it with the example. Example is the you can say that the pile of books. So books, if the books, they are placed one they are placed like this. So if they are placed one on another, that is the pile of book. And the another example can be the dishes placed one on another, it's the same example. So like the dishes, or it can be like the balls in a beaker, for example. So we have glass and the balls. So these are the dishes, these are books, and these are balls. So these are all the example of the stack. All right. Now you can see in all these example, the book or the ball or the dishes, they can always be added or removed from top. They can be added from the top and they can be removed from the top. The ball can be added from here and it can only be removed from here. The book can be added from here and the book can be removed from here. So there is only one way of one end from where we are adding the ball or we are removing the ball. All right. This is how the stack actually works. So adding and removal, and in order to, let's say, remove this particular dish from this stack of dishes, we need to remove this, and only then we can remove this. Like this is the first ball that entered, this is the second, this is the third. So if we want to remove the third second ball, what we have to do, we have to remove first three, the last ball, and then we can remove it. So the item added in the stack will leave the item added in the stack in the end in the last will stay less, means leave first, and the item added first will leave long or stay last, will leave in the end. This is the issue with the stack. All right. So the item when we are adding into the stack will always leave till the end. All right. Now, based on this, now we move on to the further second thing. Adding an item into the stack is called push, and remove an item is called pop. So when we are removing an item from the stack, it is called a pop. So this is something that you must remember. So push and pop. Okay. So we have two operations. Basically, these two are, what are these things? These two are the operations. As I said this in the start, that adding an item, what is the data? What is the ADT? Is the collection of the data and set of operations on that data. So I have just explained the collection of the data is how the data is stored in the stack. It is stored in the LIFO principle, last in first out, and they are always added from single end, from one side, and adding is called push and removal is called pop. And these are the two operations that are performed in the adding is push. Now we'll see. Then there are some pointers before we move in. Pointers or the variable that are used in the stack. One is the base pointer, and the other is top pointer. So these are the two variables that are used in the. Now moving next, and that is, as I said, adding an item is actually push is add an item. So pushing is adding an item. All right. So now I'll just show you the stack. We take an analogy of the stack. So this is the stack, for example. So the values can be added from one end. So putting the values in the stack is called push, and removing the value is called pop. All right. So when the stack is created, the way I told you the variables. So in this case, when the stack is empty, all right, now the variable. So this is the base pointer. Base pointer is always pointing to the base. So what I said, base pointer is pointing to the base. So this is the base. This is the bottom. Base pointer is pointing to the bottom. This is the bottom of the stack. The place that shows the depth. All right. So we can adding an item is, so whenever adding an item is called push. All right. So the items can only be pushed from, so whenever we add an item we increment the top pointer. Right now, when this stack is empty, for example, this is the stack. When the stack is empty, the top pointer is here. All right? The top pointer is pointing to nothing. So we can give the reference number 0, 1, 2, 3, 4. We can give the references to the location, to the addresses like 0, 1, 2, 3. So we can say that when the stack is empty, technically the base pointer is pointing to the lower bound and the top pointer is pointing to -1, or it is pointing to null. All right, this is the special case. And while adding and pushing a value into the stack, what we are doing, we are actually incrementing the top pointer. All right, so push means add an item, we increment the top pointer. So the top pointer increment means top pointer, we can write top PTR or top pointer as I write. So top pointer is top pointer plus. So we are adding an item, we are actually incrementing the top pointer. So the top pointer, when, for example, if the stack is empty and a value is added, the top pointer is going to be +1. So we'll add 1 into it. So if it is -1, so it becomes, for example, if a first value comes here, so the top pointer will become like the first push is done. Now the top pointer will be pointing to this first element. Okay, this is how the top pointer is incremented. Push is done. All right, and when the other thing is pop, which is remove an item. When there is a removal, remove an item, we again decrement the top point. So this is important, that in the stack we are only dealing with the top pointer. All right, so if the value is added, the top pointer is going to increment, and if the value is removed, the top pointer is going to decrement. So only the top pointer is either incrementing or it is decrementing. So you should remember this point in the stack. So in the stack, the values are added, it is incrementing the top pointer, and when the value is removed, it is decrementing the top pointer, and the base pointer is always pointing to the base. It's not changing. Okay, a few more things that we consider while we are adding or we are removing an item from the stack. So what is that? And when we are doing the pop, we are doing the push. This is something that you always consider, that when we are pushing something, all right, so you need to remember. So this, now I will write both of these things in front of each other so we can have a comparison. So what I said, again I will write here, push means the top pointer is incremented, and pop, the top pointer is decremented. This is the point that we have just discussed. All right, the second thing is, whenever the item is pushed, it is important if the top pointer is on the last index, all right, and there is a push, what will happen? It will overflow, because it means that there is no space in the stack. Okay, so if the top pointer is on the last index and there is a push, this means so like this is the base pointer and this is the top pointer. It means the value is placed here 9, 5, 3, 7 and this is 0, 1, 2. Now something is to be pushed. What will happen? We will not be able to push it. And this is the special case of, this means this is overflow, because this is the upper bound. The top pointer is on the last index. So when the top pointer is on the last index, we cannot push anything and we will give an overflow message. Okay. And if on the other side, when we look at the pop, if the top pointer is one index less than the base pointer, if the top pointer is one index less than the base pointer, then we can't pop. So it will lead to an underflow. All right. So what does this mean? This means this is the stack and this is the base pointer, which is pointing to the base index, to the lower bound. And if the top pointer is here, if the top pointer is here, means base pointer -1. So it means the stack is now, what is this? This shows that the stack is empty. So if the stack is empty and you try to remove something, so what will happen? Underflow. Underflow will occur. So you will not be able to remove anything from the stack. So this is how the pop works and this is how the push works. So in the push and pop, so we always consider these things, and for the same we write the code. Now we can say that the values, if the top pointer is alpha, this means now this is the push and this is the pop that we were discussing. So it means whenever we are pushing, we are saying that if the top pointer is less than, we can have a variable stack, we can have a variable that will tell us that it is the, we can have the variable that tell us that which can be stack full. So if the top pointer is less than the stack full, only then we are saying, what we are doing, we are incrementing the top pointer. All right. We will first increment the top pointer. Top pointer is top pointer +1, and then we will add the item at that place. Stack the top pointer whatever the item we want to enter, it can be added here. All right. And if the top pointer is not less than, so what we write in the else part, the else part means we are just going to output a overflow, or we'll say that stack is filled can't push. All right, this is something that you should consider while pushing something, pushing an item. And when we are doing the pop, so again the condition is that if top pointer is equal to base pointer minus 1, then output can't pop. All right, else top pointer is top pointer minus 1. All right, and before we do this, there's one more thing that we can do. We take that item. The item is going to be placed in a variable item, and then the stack first of all, the item at the index top pointer in the stack will be given to the variable item, and then the stack will be decremented, and then so this is how we do the pop. All right, and the push. This is the concept of the stack. I hope it is clear, and hope there's no ambiguity.